And in this part of the lesson, we're going to be factoring trinomials that are not perfect squares. Okay, so if we look back at our flowchart, it has three terms, but I've apparently decided that it's not a perfect square trinomial. I've answered that question no, so the next question is the leading coefficient a 1? So let's assume that the answer is yes. So if the answer is yes, let's consider this product here. So I have x plus 1, no, x plus p times x plus q, and let's go ahead and FOIL that thing out. You'll see why in just a second. Okay, so if I FOIL that thing out, I get x squared plus qx plus px plus pq. Doesn't seem very helpful yet, right? But it will be. Okay, so if this trinomial has the form, leading coefficients 1, x squared plus bx plus c, then that means that the bx term must come from the sum of the two qx plus px, right? That's the only place it could possibly come from. So if I simplify that, notice that they both have a factor of x, so I factored out. The quotient left over is p plus q, and you can switch that around. What this means then is that b, your middle term, the coefficient of the middle term, must be equal to p plus q, which were those two factors, okay, those two numbers in the original product, okay? And then finally, the c, the only place that the c could come from is the p times the q. That means the c is just p times q, all right? So if I multiply these two things together, that's going to give you my c. Okay, so remember that really factoring is this thing going backwards, okay? So I would start off with x squared plus bx plus c, and I would know that it would factor like this: x plus something and x plus something else. And those two things, p and q, whenever I add them together, it's going to give me the coefficient of the middle term, b. And whenever I multiply them together, it's going to give me that constant term of c. b is equal to p plus q, and c is equal to p times q. This is on your little flowchart. Okay, so this is what we did to start out this whole lesson. This was the warm-up questions. We're looking for two numbers that whenever I multiply them together, that's going to give me my constant term c. And whenever I add them together, it's going to give me the coefficient of the middle term b. Okay, that's what we do whenever we factor a trinomial. So another thing that you need to consider is the sign of the things. Okay, so we should be able to come up with the factors, and then I'm going to have to, further from that, decide are they going to be positive or negative, or one sign, excuse me, the bigger one positive and the smaller one negative, things like that. Okay, so in this example here, it's a generic example. It says let b be equal to p plus q and c be equal to p times q, where p is the bigger number. If you take the absolute value, who cares about the signs? So let me scroll through these pretty quickly, because what I really am going to look at, I'm going to look at a specific example with numbers, so this will make a lot of sense to you. Okay, so let's look at it with some numbers thrown in here. So the first one, the first trinomial, x squared plus 11x plus 28. So I'm looking for two things that are multiplying up to 28 and are going to add up to 11. So 4 and 7 are my two numbers, because 4 times 7 is 28 and 4 plus 7 is 11. Okay, so that's how it would factor. Now pay attention to the actual signs here. Both of them are positive. The reason why they are both positive is because I have a positive product, first of all. Because a positive times a positive gives me a positive number, but it could have also been a negative times a negative. However, I know that they both have to be positive because they're going to add up to a positive 11. So they had to be positive to begin with. Okay, so now look at the second one. Second one is x squared minus 11x plus 28. Well, now it's the same two numbers, 7 and 4, but this time they're both going to be negative. They're both going to be negative because negative 7 times negative 4 is going to give me a positive 28. And whenever I add up the two negatives, it's going to give me a negative 11. Okay, now what if the signs are different though? Okay, so on the next one, x squared plus 3x minus 28, the 28, the product is negative. The only way that can happen is if you have a positive times a negative. Okay, the signs have to be different. Now I also know that they have to add up to plus 3, positive 3. This means that the bigger number has to be the positive one. That means it's the 7 that's going to be positive, and the 4 is going to be negative. Okay? And then lastly, x squared minus 3x minus 28. Again, our two factors of 28 have to be positive and negative because I have a negative product. Have to be different. And then since they have to add up to negative 3 there, that means that the bigger number has to be the negative one. In this case, it's going to be minus 7 and plus 4. So those are the things that you have to take into account after you find your factors. Hey, I know it's 7 and 4, so now I need to figure out what's going to be positive and what's going to be negative. So, I mean, let's try it for real. Okay. So usually what I do whenever I'm going to factor these things is I list out what my product is going to be and what my sum is going to be. P for product, S for sum. So my product is going to come from the 2. They have to multiply up to 2, and they have to sum up to 3. So the only thing that's going to work, well, for 2, it's a prime number, so it's got to be 1 and 2. 1 plus 2 is equal to 3, so that's how that's going to factor. So x plus 2 times x plus 1. There's my answer. Okay. On number 2. B squared minus 20b plus 51. Okay, so my product is going to be a positive 51, and my sum is going to be a negative 20. So two things that multiply up to 51, add up to negative 20. So what about, let's see, 5 plus 1 is 6. That's divisible by 3, so 3 goes into it 17 times. So 3 and 17. 3 times 17 gives me 51, and 3 plus 17 gives me 20. Okay, so that works. Now I'll just have to figure out the signs. Okay, so I'm going to open up my parentheses, and I'm going to put a B and a B, and a 3 and a 17. Okay, now since I have a positive product, they have to both be positive or they both have to be negative. Since they're going to add up to negative 20, they must both be negative. And there I have my factors. Ta-da! Okay, so you're probably aching to do, say, 4 of them yourself, so there's your opportunity. Go ahead and pause the video. Factor those things, please. Alright, and here we are back with answers. Okay. Number one, we are looking for two numbers whose product is 56 and whose sum is 15. So two things that multiply up to 56 is 7 and 8, and they add up to 15. Okay, the signs on this one were easy just because they're both positive, so everything's going to be positive. M plus 7 times M plus 8. Okay, on the next one, product is going to be negative 84, sum's going to be negative 25. Okay, so this is one where your product's pretty big, so it might be sensible to make yourself a factor tree so that you can find some numbers that are going to work. So 84, 7 times 12, and 12, break that down to 3 times 4. And then you try to pair them up. So the first pairing that I did, maybe you did too, was 7 times 3 to get 21, and then 4, because 21 plus 4 is 25. But here's the problem. The problem is that you're trying to multiply up to a negative number, so they have to be different, which means they're going to subtract. They're not going to add up to 25 because these two numbers have to subtract. So that can't be it. So the other combo was 7 times 4 is 28, and 28 minus 3, that would give us 25. Okay, so I knew that the 28 had to get the minus sign because I had a negative sum. That's the bigger number. Okay, so n minus 28 and n plus 3. Okay, number 3 might have been kind of tricky. 45, negative 45 is our product, and they have to add up to 16. So you might have gone, oh, that's, well, maybe 5 times 7, or 5 times 9. 5 times 7. Shame on you. 5 times 9, but 5 plus 9 is not going to give us 16. Okay, so I made a little factor chart. Oh yeah, how about 15? 15 times 3. 15 times 3, well, that's not going to give us 15 either. There's one other possibility, that's 1 times 45. You're not going to get 16 from that either. That means that number 3, x squared plus 16x minus 45, is prime. You can't factor it anymore. Okay, and some of these are going to be like that. You'll see that on your homework, and you'll see it on your quiz too. Okay, number 4, my product is 35, my sum is negative 12. So two things multiply up to 35, or 5 and 7, and they add up to negative 12. They both have to be negative, though, because I have a negative sum. So y minus 5 times y minus 7. So there you go. That's how to factor a trinomial if the leading coefficient is 1. So now, in the next lesson, we're going to see, what if it's not 1?